Alright, so next we're going to talk about orthogonal vectors and matrices. For two vectors to be orthogonal means that they are perpendicular to one another, or in other words, they have a zero correlation with one another. So to test whether two vectors are orthogonal to one another, we obtain their sum of products. If the sum of products is 0, we can say that the two matrices are orthogonal. But if the sums of products is not 0, then they're not orthogonal. So we're going to consider an example using three column vectors a1, a2, and a3. And we're going to have a1 be equal to 1, 1, 1, negative 3. a2 is 1, 1, negative 2, 0. And a3 is 3, 1, negative 2, negative 1. And we can see if any vectors are orthogonal by obtaining the sum of products for each of the three possible pairings or combinations of these three vectors. The matrix algebra way of obtaining the sum of products between two vectors is to pre-multiply one by the transpose of the other, which will give us the dot product, if you recall, is just a scalar. So the dot product is just the sum of products. So we can take the transpose of a1 and multiply that by a2. And we'll get this 1, 1, 1, negative 3 times 1, 1, negative 2, 0. And when we multiply that out, we get 1 times 1 plus 1 times 1 plus 1 times negative 2 plus negative 3 times 0, which will give us 1 plus 1 minus 2 plus 0, which equals 0. So we see here, since both of them equal, when you multiply them together they equal 0, we can say that a1 and a2 are orthogonal, but we're going to do the other combinations as well. So let's take a3 and pre-multiply that by the transpose of a1. So what we get is 1, 1, 1, negative 3. We're going to multiply that by 3, 1, negative 2, negative 1. And we get 1 times 3 plus 1 times 1 plus 1 times negative 2 plus negative 3 times negative 1, which will equal 3 plus 1 minus 2 plus 3, which you can see equals 5. And for the last possible combination, we'll take the transpose of a2 times a3, get 1, 1, negative 2, 0, multiply that by 3, 1, negative 2, negative 1. And we get 1 times 3 plus 1 times 1 plus negative 2 times negative 2 plus 0 times negative 1, which will give us 3 plus 1 plus 4 plus 0, which equals 8. So once again, we can see that vector a1 is orthogonal to vector a2 because when we multiply them together we got 0. But neither a1 nor a2 is orthogonal to a3. And these column vectors can all be collected into a matrix A. So it will look like this, going down 1, 1, 1, negative 3, 1, 1, negative 2, 0, 3, 1, negative 2, and negative 1. So to find out whether the three column vectors of this matrix are orthogonal to one another, the matrix A is pre-multiplied by its transpose. So we'll have the transpose of A times A. So it'll look like going across 1, 1, 1, negative 3, 1, 1, negative 2, 0, 3, 1, negative 2, negative 1, and we're going to multiply that by A. And what we get is a 3 by 3 matrix with the entries 12, 0, 5, 0, 6, 8, 5, 8, and 15. So each off-diagonal element of the product matrix, this one, that is 0, indicates that the vector corresponding to the row of that 0 entry and the vector corresponding to its column are orthogonal to one another. So we see here we have two zeros. And we notice this is a symmetric matrix. This 0 is on the entry of A1, 2, and this one A2, 1. We see from this product matrix that the only 0 entry is in row 1, column 2, indicating that vector A1 and vector A2 are the only ones that are orthogonal to one another, as we demonstrated up here. So there you go. That's how we do orthogonal vectors and matrices, and how you determine whether two vectors are orthogonal to one another or not.